In this problem, it looks like we're going to have to do quotient rule. Looks like we have a function over a function. So we need to build that. And let's look at the formula first. So if I have something like f of x over g of x, and I want to take the derivative of this, then it's kind of like product rule, but it's quotient rule. So you'd have f prime times g minus the original f times g prime, and that's over g squared. Okay, so this is quotient rule, and we need to definitely have that in our notebooks. We need that formula memorized. So we have that, and let's say f of x equals 2x squared. All right, if I take the derivative of this with respect to x, that's just 4x. Just 2 comes down. That's easy. All right, what about g of x? If I let g of x be 3 minus 4x to the fourth, then the derivative with respect to x, notice that we're going to have to do chain rule because we have the parentheses. So the 4 comes down, 3 minus 4x to the third, but then we have to go derivative of the inside, and that looks like that would be negative 4. So that's negative 16, 3 minus 4x to the third. Okay, so we have our f prime, g prime. So we want to build this quotient. Okay, so let's do that. First, we have f. F prime is 4x. There we have it. And then g, the original g, is 3 minus 4x to the fourth minus, now we want the original f, 2x squared, times g prime, which is negative 16, 3 minus 4x to the third. All right, there we have it. And then g squared would be 3 minus 4x. Now this is to the fourth, and what we're going to do is we're going to square that. And if you remember your exponent rules, we just multiply these two numbers. So that's just going to become an 8. So I'll just write that. So instead of 4, it's just 4 times 2, which is 8. So that's easy enough. We can clean this up a little bit. Looks like we have a negative and a negative, which is going to make a positive. 2 times 16 is 32. And then we also have the x squared. So we need to look for that. So this is what I think dy dx is. We just need to clean it up a little bit. So 4x, 3 minus 4x to the fourth plus 32x squared, 3 minus 4x to the third over 3 minus 4x to the eighth. That's what it looks like to me. Yeah, that's it. So it's all about knowing that quotient rule, and then from there, building your pieces. Okay, so you definitely want to have this quotient rule at least written down, and it'd be even better if you had it memorized. I think after practicing a lot, you will have it memorized. All right, let's look at this one. This one looks like we're going to have to do product rule. Even though it's just a single x, well, we're going to have to deal with that to be like a function f times g, and so we're going to have to do product rule. And the product rule, remember, if you have f times g, then it's f prime times g plus f times g prime. All right, so I'm going to let my f of x equal x, and then f prime just equals 1. That's easy enough. G of x is going to cause me a little bit more trouble. Plus 2 to the fifth. All right, g prime, we're going to have to do chain rule. Bring down the 5, x to the fourth plus 2. That becomes a 4. And then by chain rule, we have 4x cubed. Okay, and then clean that up. 5 times 4 is 20 x cubed, x to the fourth, plus 2 to the fourth. All right, there are my pieces. Okay, so let's put them all together. What do we have? Now we have, we want f prime. That's just a 1. That's easy enough. And then g, x to the fourth, plus 2 to the fifth. I can get rid of that 1. That'll probably be more confusing than helpful. Right? Plus the original f, which was just x, okay, and then times g prime, 20 x cubed, x to the fourth, plus 2 to the fourth. Okay, I'm going to really need to clean this up. So let's do that. If I bring in the x, I have 20 x to the fourth. Okay. X to the fourth plus 2 to the fourth. Yeah, that looks good. And then we have x to the fourth plus 2 to the fifth. Okay. And then from there, well, you can factor out an x to the fourth plus 2 because they both have that. This has a 5, this has 4, so you can factor that out. What did we leave behind? We left behind an x to the fourth plus 2, and we left behind a 20 x to the fourth. I'm like double parentheses here. It's getting kind of wild. Maybe too many parentheses. That's a little better. Okay, so x to the fourth plus 20x to the fourth is 21x to the fourth plus 2 times 2x to the fourth. There, that should do it. There you go. Again, it's all about knowing what to use, when to use it. This one was product rules, so I had to build them up individually. Okay. All right. Hopefully that helps. I find the simplifying to be more complicated than actually taking derivatives, but your miles may vary. This is very similar, but different. It looks like we have product rule. We've looked at one like this before. If this was f and this was g, well, you need to build your pieces. So if f of x equals 2x minus 5 to the third, f prime of x, bring down the 3, 2x minus 5 squared. What's the derivative of the inside? It's 2. 6, 2x minus 5 squared. Okay, there's f prime. All right, what's g of x? 3 minus x to the fourth squared. G prime of x, 2, 3 minus, x to the fourth. And then the derivative of the inside is negative 4x cubed. Let's bring it together. Negative 8, 3 minus x to the fourth. Oops, I forgot the term. Let's go back. Negative 4x cubed. There you go. 3 minus x to the fourth. There we have it. There are pieces. This is product rule. So f times g is going to be f prime times g plus f times g prime. So let's build our pieces. So dy dx equals f prime, which we found to be 6, 2x minus 5 squared times the original g, 3 minus x to the fourth squared, plus f, the original f, 2x minus 5 cubed, times g prime, which is negative 8, x to the third, 3 minus x to the fourth. And then we really should clean this up. That would be minus x to the third, 2x minus 5 cubed, 3 minus x to the 4th. Yeah, that should do it. Yep. Okay, squared x to the 4th minus 3 squared 5 minus 2x to the 6th. There it is. Okay. All right. That's how I would do that one. That's number 9. So that should get you started on that one. Let's look at number 10. Number 10 is going to be quotient rule again. Okay. So quotient rule, we want to think of this as f over g. Okay. So quotient rule says that's f prime times g minus f times g prime all over the original g squared. That's quotient rule. So we got to build this. If my f of x equals 3x plus 1 cubed, then f prime of x equals 3x plus 1 squared. And that's a 3 in the inside. Clean it up. 9, 3x plus 1 squared. All right. My g, I'm going to let equal 2x plus 5 to the 5th. So g prime, 5 comes down, 2x plus 5 to the 4th. On the inside, we have a 2. So that's 10, 2x plus 5 to the 4th. Those are my pieces. Okay, so now I have to build it. dy dx. F prime first, 9, 3x plus 1 squared times the original g. Okay, minus sign from the formula. Then we have the original f, which is 3x plus 1 cubed, times g prime, which we found to be 10, 2x plus 5 to the 4th. And then the original g squared, 2x plus 5, and it was to the 5th. We're going to square it, so now it's the 10th. All right, that's not so bad. Now, the last step, you've probably heard me say it a million times. We got to clean it up a little bit, but we're almost done. Minus from the formula, let's bring that 10 out. 3x plus 1 cubed, 2x plus 5 to the 4th, all over 2x plus 5 to the 10th. And there we have it. All right. So it's all about building. You got to build up to it. That would be my advice. You got to build up to these things. So I like to, as I say, I look at my formula. I've got it so I can refer to it. I break down my pieces and then I build it. All right, this, if I remember correctly, this one is more annoying to simplify than actually to do. I'm going to rewrite this a little bit because I prefer to work with exponents rather than square roots. So I'm going to say that's 1/2. Okay, I know how to deal with that a little bit better. And here we're going to have to deal with chain rule because we have an exponent and quotient rule. So we have to deal with both. What's going to be the easiest way to do this? So if u equals 4 minus x over 5 plus x, then df, let's go back, sorry. Then f itself, let's say f of u, just equals u to the 1/2. So df du equals 1/2 u to the negative 1/2. And if you like to get fancy, square root of u, okay? So we've seen this before, but we need to remember to do that. Okay, I'm going to switch colors because I need to build my quotient rule now. Quotient rule f over g prime is f prime times g minus f times g prime over g squared. And that's what we have to do here. Okay, so my f of x equals 4 minus x, and then f prime of x equals, looks like it's just -1. That's easy enough. G of x, 5 plus x, g prime of x just equals 1. So at least those are kind of easy. All right, so can we build this? Can we build our quotient rule? Okay, the first one is f prime, which is -1, times the original g, 5 plus x, minus from the formula, and then g, well, I should be more careful, 4 minus x times g prime, which is just 1, that's no change. And then over the original g squared, 5 plus x squared. All right, and let's clean this up a little bit. Minus 5 plus x minus 4 minus x over 5 plus x squared. Okay, I think we're done with this. I'm going to clean this up some more so I can use it to try to simplify. All right, what do we have? We have -5 minus x minus 4 plus x all over 5 plus x squared. Is there anything I can cancel? Yeah, it looks like those x's go away on the top. -5 minus 4 would just be -9. 5 plus x squared. Okay, that looks like it. So that's the quotient rule part. Okay, and remember, df dx is going to be df du times du dx. Okay, and really what I found here is du dx. Okay, this is my df du. Okay, so let's build it. I'll switch to black. So my df du is 1 over 2 root u. And actually, there's going to be a part where it's easier to see. Sorry, I'm going to go back on my word here. It's going to be easier to see if I leave it as an exponent. Excuse me, sorry about that. 4 minus x, 5 plus x to the -1/2. Okay. Times du dx. Plus x squared. Okay, now I knew this because I did the problem before, but hopefully this video will help you see that. You have this going on, and what's going to happen is you have a few things you can do with the exponents. Okay, so you have 1/2. If I flip this upside down, I mean, this is all this exponent business. It is technically just intro algebra, but it's embedded inside a, calculus problem. So it's kind of hard to remember that's what you're doing. And I think I don't really need that anymore. So there's an exponent rule that we can use and abuse right now. And that is you have 1/2 over 2. So you have 1/2 minus 2, which is 1/2 minus 4 over 2, which is -3/2. So you have this 5 plus x over 2 And that means you're going to have a negative 3/2 5 plus x, which means we'll just have a 3/2 in the denominator. Okay, so that's what's going to happen with 5 plus x squared. 1/2. And we've talked about that. So then we have 1 over 4 minus x to the 1/2 times negative 9, 5 plus x to the 3/2. Okay, just need to put this all together and we have it. Negative 9 over 2, 4 minus x to the 1/2, which is just square root, and then 5 plus x to the 3/2. And there you see it, okay? Again, this is all simplifying. I find the simplifying to be more difficult than the actual problem, but you just kind of have to work with it, all right? And it's always good to try. I mean, Math Lab is pretty good about accepting, many different things. It's one of the better homework systems. So sometimes it's worth trying if you're more comfortable with trying to plug this in to try to get it to go, okay? All right, let's see what this one brings us. We have find dy dx, we have u equals du, and then we have u equals this. All right, fair enough. So y equals square root of u, okay? So what does dy du equal? Well, we've played with this a lot. U to the negative 1/2, and then maybe I'll write this down just so I remember. 1 over 2 root u. Okay. Now, what's going on with du dx? Bring down the 2, and I think that's it. Okay, so du dx is just 2x, no problem. So let's build it. Dy dx equals dy du, whoops, times du dx. All right, 1 over 2 root, and our u is defined to be x squared plus 3 times du dx, and that's 2x, okay? So that's 2x over 2 root x squared plus 3. We can see that's the answer, and I would even argue, frankly, you could just reduce the 2, but the computer doesn't seem to mind, okay? So there is our answer. Okay, let's see what we have here. We have y equals u to the 49th, and then we have u is defined as this polynomial, okay? And we're asked to find dy du. Well, that's not so bad. Dy du, bring down the 49, u to the 48th, okay? That's not too bad. It wants du dx. So this problem is really just having us break it down ourselves. Bring down the 3, that's going to give us a 15 x squared. Bring down the 2, 8x. All right, got that down. Now dy dx. Remember, dy du dx. All right, dy du, 49, and then our u is 5x cubed plus 4x squared times du dx. Du dx is right here, 15x squared plus 8x. There we have it, okay? So this problem is just having us walk towards the derivative, just walking towards it. Okay, not too bad if you walk the path they tell us to. All right, what do we have here? Find dy dt for each pair of functions. Y equals x squared minus 8x x equals t squared plus 2. This is very similar to the u's, except we're dealing with x's, okay? So we have y equals x squared minus 8x, and x is defined to be another variable. So this is similar to the u, we just need to do it. So we know that dy dt is going to be dy dx dt. Okay, so we need to find those. All right, what is dy dx? That's going to bring down the 2x minus 8. Not too bad. And then what is dx dt? That's 2t. Okay, that's not too bad. All right, dy dx I found to be 2x minus 8. We're going to need to sub in t in a moment. Times 2t. All right, now we just want t's. So this is 2 times t squared plus 2 minus 8 times 2t, getting close. All right, if we like, we can bring this in. 2t squared plus 4 minus 8 times 2t, getting really close now. 4 minus 8 is just 4. So we have 2t squared minus 4 times 2t. And if we like, we could distribute that. So we have 4t cubed minus 8t squared. Okay. I think I got that right. 2t, 4, yeah. Yeah, and then if you want, you can break that up. So you have t squared 4t times t minus 2. And then you can also write that as the same thing. Okay, not too bad, but kind of confusing. So it looks like the computer multiplied it right there. So that's how they got their version of the answer, but that's no problem. So that's 4t squared plus 2 minus 16t. So it's frankly, they're all the same thing, but that can be kind of confusing when you're looking at that. So thought I might mention it. Okay, the next one I wanted to show was 17 because it has this composition of functions. And even though we've been using it with chain rule, I just want to make sure that it makes sense. So we have f of u equals u cubed, g of x equals 5x cubed plus 4, okay? They want f of g prime evaluated at x equals -1. So we need to first find what is f of g, and then we'll find the derivative of that. So f of g means you're plugging g into f. Okay, so that means this goes inside here. So that's 5x cubed plus 4 to the third. Now we want to take the derivative of this. So 5x cubed plus 4 squared times the derivative of the inside, or the derivative of g, which would be 15x squared. Okay, there we go. And really, that would be fine. if we want to leave it like that. I mean, we don't really need to clean it up since we're going to plug in a number. So f of g prime evaluated at -1, we just need to plug this in. So 3 times 5 -1 cubed plus 4 squared 15 -1 squared. There you go. Okay, so you're just evaluating this. So the nice thing is when you don't have to clean it up quite as much if you're just going to evaluate it as a number. Okay, and then from there, we find that that was 45. Okay, but you'll probably have different numbers for your problem.
I didn't get that. Could you try again?
Let's clear this. And here we have a first word problem. The position of the particle moving along a coordinate line is s equals root 61 plus 14. So they're telling us the position. S is in meters, T is in seconds. Find the rate of change at T equals 5. Okay, rate of change, that's what we've been talking about. Find the derivative. S equals root 61 plus 4T. Okay, I'm going to rewrite this as 1/2. So if I want to find the derivative, 1/2 61 plus 4t -1/2, and then the derivative of the inside would be 4. Okay, they want it evaluated at 5, so s prime evaluated at 5 is 1/2 61 plus 4 times 5 to the -1/2 to the 4. All right, and for that I got 2 ninths. I really got 0.2 repeating, 0.2222, but I had to convert that to a fraction, okay, because it wants a simplified fraction. All right, it's not too bad, but you know, it's a word problem, so that can kind of mess us up a little bit, but it should be fine. All right, let's see what 23 brings us. Here, we're asked to find the second derivative. How on earth do you find the second derivative? Well, you got to find the first derivative, and then you take the derivative of that derivative. Okay, so let's do it. So first we need to find dy dx. And before I even do that, I'm going to clean this up for a little bit of success here. So let's find the derivative of this. So dy dx, bring down the 5, that's 6 over 5 times 5. We see that that's just going to reduce to the 4th minus 2. Okay, so that gives me 6x to the 4th minus 2. Now, to find the second derivative, take the derivative of this, d squared y dx squared. Bring down the 4. 4 times 6, 24. X to the 3rd constant goes away. So we're left with 24x cubed. Okay. So if you want to find the second derivative, that's what that 2 is telling us. You take the derivative of the derivative. What's also interesting to me is we were talking about the position. So the second derivative is the acceleration. So that's kind of interesting. If you have a position of a particle, take the derivative of that. That tells you the velocity, or you could say the speed. And then the derivative of that is the acceleration. So you see that in your car, you'll see the speed that you're going, that's velocity. You'll see the acceleration. And then the third derivative, the derivative of acceleration, is called the jerk. That's the jerk. d3y dx cubed. That's the jerk. That's how jerky it is. Okay. All right. It's kind of interesting. I wanted to show 29. Let's see if we can talk about it. Here it wants the second derivative. We see that f double prime. All right. Well, to find the second derivative, I got to find the first derivative. Okay. So how am I going to do that? Well, it looks like chain rule will apply. Bring down the 7, x squared plus 5 to the 6. What's the derivative of the inside? 2x. All right. I'm going to clean that up a little bit. That would be 14x x squared plus 5 to the 6. All right, that's my first derivative. Now, what do I need to do? I need to take this derivative. Okay, fair enough. So let's take the derivative of this. So f double prime of x. The 6 is going to come down. And so the 14 becomes 84 x squared, oops, plus 5. 6 becomes 5, fair enough. Now, what's the derivative of the inside? 2x. All right, 2 times 84, 168. X times x squared, x squared plus 5 to the 5th. Okay, so we should note, we found this, but note this is technically product rule. So we need another term there. So I have to add on, take the derivative of this part. That's not that bad. Just get rid of the x squared plus 5 to the 6. So because the first derivative ends up making us do product rule, we have to tack on the derivative of the second piece. So that goes right there. And there's our finished product rule. Okay, finished product. All right, hopefully that makes sense. Hopefully that's helpful. Okay, 2, 2, 2, 2, 2. Let's see what 31 brings us. It's going to be another quotient rule. But let's see, we have f over g. And we want to take the derivative of that. You have f prime g, f times g prime, g squared. Okay, so let's find it. If we have f of x equals 3x plus 2, f prime of x equals 3, g of x, I'm going to let 2x minus 3, g prime of x equals 2. All right, so at least it's not too bad. So I think y prime, the first derivative, would equal f prime 3 times the original g, 2x minus 3, minus the original f, which is 3x plus 2, times g prime, which is 2, over the original g squared. Okay, now I think we should probably clean some things up before we take a derivative again. So what does that give me? 6x minus 9 minus 6x plus 4, 2x minus 3 squared. Okay. 6x minus 6x goes away. And I've got to watch my 4s and 9s. That's negative 9 minus 4. So that gives me 13. Negative 13. 2x minus 3 squared. Okay, now we want to take the derivative of this. So this is y prime. So now we want to take the derivative of that. So I need to get rid of some stuff because we don't need this anymore. All right. Now, we could do quotient rule. That's fine. You can do quotient rule if you like. But I think what I'm going to do is I'm going to invoke the exponents. Since the top doesn't have an x, I'm just going to play with my exponent. So if I take the derivative of this, I just have to do chain rule. Okay. So y double prime equals negative 13 times negative 2, 2x minus 3. Negative 2 minus 1 is negative 3. and then derivative of the inside is just 2. So we're going to have negative 13 times 2, 26 times 2, 52. 2x minus 3 to the negative third. 52 over 2x minus 3 cubed. There you go. All right. It's not too bad, but with all those derivatives, it can be kind of confusing. And then we started with quotient rule and we ended up just having to do chain rule. You could still do quotient rule there, but I wouldn't if I don't have to. Okay, so hopefully that helps. All right, I think I had another problem. Yeah, 37, I want to talk about how you can do it. It's not that bad, but you have to know what to do. They give you the function, okay? They want you to find the derivative evaluated, and they might change the numbers on you. We have to find the derivative evaluated at 2, derivative evaluated at 3, derivative evaluated at 4, okay? That's not too bad. This is just a polynomial, so that you can see what my derivative ended up being. I evaluated 2, which just means I plugged in 2, and that's thousands of dollars per month. That's rate of change. Rate of change. So evaluated at 3, evaluated at 4. Okay, so that's not that bad. That's pretty easy, in fact. Then you have to find the derivative of the derivative, second derivative. So the 2 comes down, that's 18. This t goes away, so minus 100. You can see where that comes from. Then we have to evaluate it 2, 3, 4. Okay, still not that bad, not that big a deal, but what's a little confusing is this is a rate of change of a rate of change. So it's per month squared. This is the change of the change, all right? Notice these are negative numbers. So what's going down, oh, I'm sorry, what's going on is that it's slowing down. So if your acceleration is decreasing, that's what we see. If it's decreasing, then you're slowing down. Right? And then the end says after 2 months, okay, it's increasing. We have a positive slope here, but it's slowing down. Okay. After 3 months, still increasing. That's a positive slope. We see it's slowing down. Okay. Still slowing down. After 4 months, now it's decreasing. This is negative. So if you have a negative slope, you're definitely decreasing. And we see the decline is getting worse. Okay. So it's decreasing, decreasing. All right. So that's a little bit confusing, and we didn't go over that in class. So I definitely wanted to give you a heads up on that. All right. I hope this helps. Please reach out, email me if you have any questions, and I'll see you next time.